Hi, today I would like to discuss about the topic of eigen values and eigen vectors. So before going to the vector, so what do you mean by a vector? So generally, a vector is a directional quantity, right? So here I am considering one transformation, that is xy domain. You want to change the domain from xy to some uv domain. So here some point is there, that is 2 comma minus 1. You want to change this value here to a position of 6 comma 0. So why we discuss about these things? This is one of the application for the eigenvectors. So where we are using the application here. So our next one is, so one matrix A matrix is there and one unknown matrix is there, is equal to something, that is some value matrix. So that is Ax is equal to B. So this is generally to find a particular equation. For example, consider x plus y plus z is equal to 1 and x 2x minus y plus 3z is equal to 5 and 6x plus y plus 4z is equal to 2. So if you want to find out the values of x, y, z, so what we do? We take the coefficients of x and y, z as one matrix, and you take the coefficients of x, so that is x, y, z and one matrix, and 1, 5 to another matrix. So see here, this is one matrix A, and this is an x matrix, and this is a B matrix. So A into x is equal to B. To find out an unknown values, we use the eigenvalues and eigenvectors. So this is to find out a particular system. So this is a system to find out a particular system. So in this case we are having homogeneous as well as non-homogeneous. In homogeneous, x is equal to 0. That is 0. Whenever the big matrix is 0, x is equal to. So okay, under the eigen, we want to find values of so vector value a equal to eigenvalues where x is equal to x lambda with an consider scalar a quantity expanded with this scalar matrix rectangle is the values that x and after these unknown is what I find out using the scalar matrix. Guys, we can one function. So I'll give an example regarding the lambda values. So 5, 4, 1, 2. I'm changing this entire Ax is equal to, I'm writing the lambda x to the left hand side, that is equal to Ax minus lambda x is equal to 0. A minus lambda I of x is equal to 0. So which is looking like Ax is equal to 0 solution. So whenever this is an homogeneous solution, so we for that particular the A minus lambda I is equal to 0. So this is the value for a non-zero solution. For a non-zero solution, A minus lambda x is lambda I is equal to 0. So now I am applying the names. This is an A matrix. So find out the eigenvalues. These are called nothing but the eigenvalues. We have to find out the eigenvalues. 5, 4, 1, 2 matrix minus lambda of identity matrix. So I is nothing but the identity matrix. that is 5 minus lambda, 4, 1, 2 minus lambda. A minus lambda equal to 0. So this is that. Find out the depth for that lambda, that is AD minus basic. 5 minus lambda into 2 minus lambda minus 4 is equal to 0. So 5 into 2, that is 10 minus 2 lambda minus 5 lambda plus lambda square minus 4 is equal to 0. It is lambda square minus 7 lambda plus 6 is equal to 0. So lambda minus 1 into lambda minus 6 is equal to 0. This is quadratic equation. So 2 into 6. So that is 6 into 1 and 6 minus 6. Minus 6 minus 1, that is minus 7. 6 into 1 is 6. So I get it that lambda is equal to 1 and 6. So these are the eigen values. So how we can find out a particular eigen vector is nothing but, so we have to substitute lambda is equal to 1 case, lambda is equal to 6 another case. If you are putting lambda is equal to 1 here, so what you are getting, that is 4 and 1 and here also 1 into, so whatever the matrix you are writing, that is I am writing x1 and x2 is equal to some zero matrix, vector matrix. So 4x1 plus 4x2 is equal to 0 and x1 plus x2 is equal to 0. From this, x2 is nothing but minus x1. I am assuming my x1 as minus lambda. So I am assuming x1 as minus lambda. So now what is the matrix x1, x2? Vector matrix is nothing but lambda alpha minus alpha. So from this, take common. From this, take the common value that you are getting, alpha 1 and minus 1. So this 1 and minus 1 is nothing but eigenvector for alpha is equal to 1. So alpha is equal to 1. So what is the eigenvector? 1 minus 1. Similarly, if you want to find out for 6, you can do the same analysis. So what here the values will be changing. Here it is changing is minus 1 and here it is changing minus 4. Right? Minus 1 and minus 4. So from that you are writing again the expressions. What we are getting the values as minus x1 plus 4x2 is equal to 0 and x1 minus 4x2 is equal to 0. So x1 is equal to 4x2, assume x2 as alpha. So that is 4 alpha is the eigenvector. From this, considering the alpha as common, 4 unknown. Right? So this is now the eigenvector. So what is the necessity to do the eigenvector is nothing but we are calculating the unknown values. I already told you to find out the unknown matrix. We are finding out the unknown matrix using particular lambda. So whatever the eigenvalue, we are changing that. So simply I say that about x and y domain. I am interchanging the x and y domain to the u and v domain, right? The x and y domain is changed to u and v domain. The same way you are raising u v is equal to some A matrix is of x y. So you are changing the x and y domain to the u and v domain. So we are trying to do that. We are finding the values. That is the application for that particular value. So you are finding the value lambda is equal to 1 and 6 for the particular matrix of 5, 4, 1, 1, 2. So particular matrix 5, 4, 1, 2. What is the eigenvalues? Lambda is equal to 1 and 6. Now I am trying to do a matrix, 3 by 3 matrix. If I find out the values, eigenvalues will get some lambda 1, lambda 2, lambda in the same fashion. Suppose here 1 5 minus lambda, 2 minus lambda, 3 minus lambda, some 1, 2, 3, 4 and 5 and 2. For example, consider one example. So after finding the values lambda 1, lambda 2, lambda 3 you are getting. So there is a shortcut to find out the particular eigenvalues. Simple thing. So this is a property in your mathematics methods. That is a one properties. Lambda 1 plus lambda 2 plus lambda 3 is equal to trace of matrix. So what do you mean by trace of a matrix? That is nothing but the sum of these matrix. Okay? And sum of these elements, that is diagonal elements, sum of the diagonal elements is nothing but the trace of a matrix. Diagonal elements is nothing but the trace of the matrix. This one and next to lambda 2, lambda 3 is equal to the set of the particular matrix. If you use these two formulas, we can solve the position. You can find out the values easily. So by plus C. So what is 5 is equal to 1 plus 3 is 7. That is, so what is your here plus 7 6 7. I'm cross-checking the value of right. But we have is talking about the 5 product of 10 minus that is 2, 10 plus is 4. Plus you are 6, right? If our minus is 2 value, getting 6. Similar fashion, A is a matrix, for that lambda is the eigenvalue. So now I want A inverse. So I am saying that this is 1 by lambda. How it is coming to 1 by lambda? See here. This is Ax is equal to lambda x. Now I am multiplying in the both sides with A inverse. Okay. So A inverse into A x is equal to A inverse into x of lambda. So this is a scalar quantity we can write in any side. So what is this value? This is identity matrix. Identity into x is equal to lambda A inverse of x. So what is this value? This is simply x. I am pushing this lambda to this side. That is 1 by lambda x is equal to A inverse of x. So now I am saying for A it is lambda. For A inverse it is 1 by lambda. Simply 1 inverse. Again I am using another property. I am doing another property, that is a property and rule shortcut formula. A square is nothing but lambda square. Simply whatever the power is there, this is the power. So I am now multiplying with A with both sides. So A of lambda x. So this is A square x. This is lambda of Ax. So what is Ax? That is nothing but lambda x. So lambda x. So that is lambda square x. This is another property. So previously we discussed about the trace of matrix is nothing but sum of eigenvalues, and product of eigenvalues is nothing but that of A. If you remember these two properties, you can simply solve the 3 by 3 matrix lambda values easily. Shortcut, that is in speed way. So if you not remember, there is no problem. You just simply do the Ax, A minus lambda x, lambda that is equal to 0. And just find out these values. These can be written, these can be called as characteristics equation. This is characteristic equation. Okay. This is the characteristic equation.